All right, factoring. We'll start this and then finish it Wednesday. Factoring. So find all factors of 24 and list them in ascending order. The factors of 24. What you're going to do here is what numbers go into 24, basically. Okay, what'd you say?
8 times 3.
8 times 3. What this is, I'm going to write it a certain way. When you get stuck in factoring, like y'all can use a calculator. So what I do is just take the calculator and just start dividing it. If I divide it by 1, I get 24. If I divide it by 2, I get 12. If I divide it by 3, like she said, I get 8. If I divide it by 4, I get 6. If I divide it by 5, it doesn't work. And I can stop there because 6 is right here. Like the numbers kind of loop around right there. So you, you can try 7. And what I mean by it doesn't work is it doesn't get a decimal, right? Once you loop around, you do not have to keep going, though. Like 5, the next number is 6. So ascending order, if you did that, would be 1, 2, 3, 4, 6, 8, 12, 24. I'm not for sure if Alex makes you do that. But all those numbers are factors of 24. This idea really helps you if you get stuck on a hard number. Like if I'm trying to figure out the factors of, I don't know, let's do like 108. Let's change it to like 108, okay? Well, I don't know what that is off the top of my head. So I'm just going to go and I'm going to say divided by 1 is 108. Divided by 2 is 54. Divided by 3 is, that actually does work, 36. Divided by 4 is 27. Divided by 5 is a decimal. You can do this in a calculator pretty quick. Divided by 6, does that work too? 18? Yeah. Divided by 7, 91, 98, 105. I don't think that works. Divided by 8 does not work. Divided by 9, that's 12. Divided by 10, that doesn't work. Divided by 11, that doesn't work. And I can stop at 11 because 12 is right here. You can always stop when you get to that next number there. Okay, so those would be my factors. Like it does, I did that in my head in what, like 12 seconds. You can do it in the calculator in like 5 seconds. Okay, just divided by 1, divided by 2, divided by 3. When you get stuck on these hard factoring problems, that is the best way to do, is to make a list of factors like this. Okay, you'll see. Well, I'll do this for sure on Wednesday, and you'll see that. All right, so factoring a linear binomial, you are just going to look at the factors, the greatest common factor of 6 and 12. So if you need to list the factors of 6 and you need to list the factors of 12, you can do that, and we showed you how to do that. And you take the biggest one. So what the biggest number that I can divide 6 and 12 both by is 6. Okay? What I am technically going to do from here on out, and I probably won't write this every time, is divide everything by 6. So 6x divided by 6 leaves me with x. Negative 12 divided by 6 leaves me with negative 2. You can distribute back through to check your answer. That's kind of what I do instead of writing it out with negative to check your answer. Distribute back through. Like if I did 6x is 6x and 6 times negative 2 is negative 12. Okay. You can always take 2 seconds to like double check that in your head real quick. I'll kind of show you what I mean by that. So if I have 8x plus 16, my biggest number that I can divide 8 and 16 by is what? 8, right? So I pull out the 8 and I have an x. 16 divided by 8 would be 2. Okay? And you can always check it real quick. 8 times x is 8x. 8 times 2 is 16. Just out of, to like show you if something went wrong here, what if I pull out a 4? I'd get 8 divided by 4 is 2x. 16 divided by 4 is 4, right? Well, if I accidentally pull out a 4, is there something I could pull out of this? 2 and 4? I could pull out a 2, right? So then I pull out a 2, and I get x plus 2. So I pulled out a 2, and then I pulled out a 4. Well, that's 8, okay? So, like, if you pull out a number too small, that means you can pull out a number again and do that. So always try to pull out the biggest number, but if you happen to pull out a number too small, that means you can pull out a number again, which you multiply the numbers on the outside, if that makes sense. So try not to do that, but if it does happen, you should be able to catch it pretty easily because the numbers will be smaller to work with. All right, greatest common factorial. I'm sorry, not factorial. I'm in stats mode there for a second. Greatest common factor of these two. The greatest common factor, as I think about it different, it's the biggest number you can divide them all by, okay? So the biggest number that I can divide 12 and 18 by is 6. That's the easy part on this one, right? Is 6, okay? What you do with the x's, what you do with a variable, is you take, it's what I'm dividing out, okay? So if I tried to take, it's either going to be 3 or 2, we know that. Because there's 3 here and 2 here, right? But if I tried to take 3 x's from here, I'd be fine, right? But what happens if I try to take 3 x's from there? I can't take 3. So when you see a variable, you actually take the smallest exponent because I cannot take more x's than I'm given. I'm only given 2 x's here, so I cannot take more than 2. So I get 6x squared there. One of the ways you can check to make sure you do these right, if I divide this by 6x squared and divide this by 6x squared, I'd get 2x on this one and I'd get 3 on this one. Is there anything common between 2 and 3? That means I did it right. Okay, I can't divide anything else out. Can't divide anything else out. So we're good. That's a way to check it. Okay. I don't know if this one's a good one to show you. Okay. So 15 and 25, most of y'all probably see that that's 5. Like 5's the biggest number I can take out of there. What about my y's? Do I take 4 y's or 2 y's? 2. You take the smallest one. Okay. I just wanted to show you real quick what happens if you don't take the biggest one. Oh man, it's raining. Top's off my Jeep. Okay, so like if I was doing this one and I didn't take the biggest number, what's the first number that comes to your head? Is 72 and 24?
9.
Not 9 because 24. 8, right? If I take an 8 out, I'd get 9 and I'd get 3. Okay, we know it's x cubed, right? It's the smallest exponent. Well, can I take something out of 9 and 3? I can take 3 out of there, right? And I'd get 3 and 1. I get 3 and 1. Well, I can't take anything else out of 3 and 1 besides 1, and you don't do that. So what my answer actually here is the biggest number that I should have took out is 24. Okay? So you can kind of do the greatest common factor that way. Just divide it by something, and then you'll start divide it by a small number, and then you multiply everything that you divided by. Does that make sense? Like I said, you always try to divide by the biggest thing, but sometimes you get, oh no, I divided it by 8 and I got 9 and 3. Well, if I divide those both by 3, 8 times 3 is 24. I could have just divided by 24 from the beginning. All right, what if you have 3 of them? Same idea works here. Same idea, what 6, 9, and 12. The biggest number I can take from there is 3. And you take the smallest exponent. And again, that whole dividing it out, that's really just to check your answer to make sure it's right. You don't have to go through that every time. So what if you have x's and y's? Nothing really changes. You're going to take the smallest exponent from each variable. So 8 and 12 would be 4. And then my x's, I got 2. And my y's over here, it only has 1. Okay, so you take the smallest exponent from each one. I can only take one y from this side, so that is going to be my greatest common factor. All right, so where we're going to mainly use this is factoring out from a polynomial. So this is just putting pluses and minuses in it, but everything's going to work the same way. You have the 4x cubed, a negative 8x squared, and a 12x. So the biggest number that I can take from those is 4. And the most amount of x's that I can take is just 1 because of this one right here, right? But now on this one, I actually have to factor it out. Okay, so 4 divided by 4 would be 1. I take away, there's 3 x's, I take away one of them, so that would be x squared. This is the way that I think about it. 4x times x squared would be 4x cubed, so I did it right. Negative 8 divided by 4 would be negative 2. I have 2 x's, I take away one of them, so I have x. 12 divided by 4 would be 3. Take away that 1x, that's all that's left. So again, to check your answer, you can distribute it back through. So here, 12a squared b cubed minus 8ab squared plus 4a cubed b. All right, so just do it one step at a time. 12, 8, and 4. The biggest one I can take out is 4, right? I got 2 a's, 1 a, and 3 a's, so the most a's I can take out is 1. My b's, I have 3, 2, and 1. So the most b's I can take out is 1. If you need to, on a harder problem like this, you are more than welcome to come over here and say, okay, I'm going to take a 4ab from this one, a 4ab from this one, and a 4ab from this one. If it helps you to write that out like that, that's fine. Okay. Oh my goodness, stop hitting the keyboard. All right, so 12 divided by 4 is 3. There's 2 a's, and I'm going to take away one of them, so that is 1 left. There's 3 b's, I take away one of them, so there's 2 left. So that's the first one. If you need to work it out like this, that's fine. Negative 8 divided by 4 would be negative 2. There's 1 a, and I take it away that a, so the a's go away. My b's, there's 2 of them, and I take away one of them. So there's 1 b left. 4 divided by 4, they cancel out. I got 3 a's. I'm taking away one of them, so I got 2 a's left. The b's, there's one of them, and I take away one of them, so there's no b's left. Again, a quick check. 4ab times a squared would be 4a cubed b. You can always distribute it back through to check it. All right, this is probably the last one. I think that'd be a good stopping point for us. If I'd stop hitting the keyboard, I don't know why it's doing that so easy this time. x plus 2 squared plus 3x plus 2. All right, these are just kind of weird, to tell you the truth. That's why I want to do it to finish it, and then we don't have to do it. You can look at this and see what's common, right? They both have an x plus 2 in it. So I can actually factor out an x plus 2. If I factor out an x plus 2, this is what's weird. I have an x plus 2. I have one of them left, right? Because there's two of them right there. Because x plus 2 times x plus 2 would be x plus 2 squared. Does that make sense? And then if I take away this x plus squared, I only have a 3 left. And we could probably combine like terms, but most of the time when you factor like this, they want you to leave it like this to show that I'm taking this times this would be x plus 2 squared, and this times this would be 3 times x plus 2. So I'm actually pulling an x plus 2 out of both of those. We won't use that concept too much. I actually kind of teach that a slightly different way, or at least think about it a different way. This is what it will look like on Wednesday, is something like this. But the way that I think about this when we do it, and I'll kind of say it because it will come, they both have an x minus 1, right? So if I factor out an x minus 1, that leaves me with a 5. I'm going to write a different color here real quick. That leaves me with a 5 and a negative 2x. The way that I will say this on Wednesday when we do this is I will say the insides come together and then the outsides come together. That's the way that I think about it. I'm going to erase those lines for today, though, because technically we're talking about factoring it out. That's what you're doing, is you're factoring out an x minus 1. So if I took this whole thing times 5, I would get this. And I took this whole thing times negative 2x, I would get this. Kind of weird to think about it when you got a bunch of terms there. But that's the only topic that I'll really talk about like that. So that kind of starts us on our factoring journey here. I believe all the other stuff I will save for Wednesday.